For double replacement reactions, in order to get a double replacement reaction, you need to meet one of the following conditions. You need to make water or a precipitate. Water, you know, H2O. And then a precipitate, we need to check the solubility rules. And to check the solubility rules, we need to go to our reference tables on page 6. The solubility rules are up here at the top. And a precipitate is a solid that forms. So a precipitate is something that is insoluble or not soluble. So we need something that fits over here. So I'll walk you through some examples. So this first one, we have copper 2 sulfate plus sodium hydroxide. Well, first, we got to figure out what the heck we're even going to make. So if we look down here at the bottom, we can see the template for double replacement reactions is that AB plus CD makes AD plus CB. So copper sulfate plus sodium hydroxide will make copper hydroxide plus sodium sulfate. So this is going to make copper 2 hydroxide because copper has a +2 charge, and in double replacement reactions, charges of elements won't change, but don't worry too much about that. So it's going to make copper 2 hydroxide plus sodium sulfate. Now for this reaction to happen, we need to make a precipitate. So let's look, we've got copper and we only need to check on the product side here. So we're looking over here. So we've got copper 2 hydroxide. Well, this says carbonates, phosphates, ammonia. All hydroxides are insoluble except for group 1. Well, copper's not in group 1. Copper's over here. Strontium, barium, and ammonium. So it's not an exception. So this is insoluble. That's our precipitate. So we have a reaction. All right, I want to explain this reaction in a little more detail. We have the copper 2 sulfate plus sodium hydroxide making copper 2 hydroxide plus sodium sulfate. The first thing you can notice is that this equation is not actually balanced yet because I have 1 sodium on the left and 2 sodiums on the right, and the same with our hydroxides. So I need a second sodium hydroxide, which is why there's a 2 in front of the hydroxide in the balanced equation. Now, as for what's actually happening, we said that copper 2 hydroxide is our precipitate. Now, when you put these things into solution, these reactions take place in aqueous solution where these things are dissolved in water. And when you take a soluble ionic compound, as these things are, and you put them into water, they break apart into their individual ions because they are soluble. And as they move around, they can interact with each other. If the copper comes in contact again with the sulfate, well, it's still soluble, so nothing happens. Copper and sodium won't combine, they're both positively charged. Hydroxides and sulfates, they won't combine because they're both negatively charged. But if a copper and some hydroxides meet up, that produces something that's no longer soluble, and so it will sink to the bottom of the container, forming a precipitate. And you're left with sodium ions and sulfate ions still floating around in solution. And so if we want to actually better represent what's happening, we can write what's called a net ionic equation, which just shows what actually occurred, which is where the copper with a +2 charge reacted with 2 hydroxide ions with the -1 charge to form copper 2 hydroxide as a precipitate. So this is what's called a net ionic equation for this reaction. If we check out the second one, sodium carbonate plus calcium chloride, well, that's going to make sodium chloride plus calcium carbonate. Also, I forgot to balance this equation up here earlier because I need to put a 2 right there. If we balance this equation, we put a 2 right there. Now, we need to find our precipitate. Let's check sodium chloride. Well, all nitrates, acetates, ammonium, and group 1 salts are solubles. In other words, anything that has an element in group 1, and we're going to kind of ignore hydrogen for this case, but anything that's got an alkali metal in it, which sodium is always soluble. There's no exceptions to that. So that is not a precipitate. Then we have calcium carbonate. This says all carbonates are insoluble or are a precipitate. These are our precipitate. Except for group 1 and ammonium. Well, calcium's in group 2, so we have a precipitate, we have a reaction. If we look at this reaction, we have sodium carbonate plus calcium chloride makes calcium carbonate plus sodium chloride. We have to have the 2 for this one, two sodium chlorides to balance the equation out. Now, when you dissolve sodium carbonate into water, it breaks apart into sodium and carbonate ions. Calcium chloride dissolves into calciums and chloride ions. So these things can move around in solution. Whenever sodiums and chlorides come into contact with each other. We'll look at this next one, copper 2 sulfate plus hydrogen chloride or hydrochloric acid. That's going to make copper 2 chloride plus hydrogen sulfate. And balance it real quick. If we check our solubility rules, all chlorides are soluble except silver, lead, and mercury 1. Well, this is copper. And then all sulfates are soluble except calcium, strontium, barium, mercury, lead, and silver. Well, this is hydrogen sulfate, so that's also soluble. So we have no precipitate. That means no reaction. This reaction does not actually happen. They are still soluble, so it can stay broken apart and floating around in solution. But whenever a calcium and a carbonate come into contact with each other, they form a precipitate and sink to the bottom of the container as our solid. So a net ionic equation would say that calciums with a +2 charge plus carbonates with a -2 charge form calcium carbonate as a precipitate. And then this last one I want to show you real quick. This is lead 2 nitrate plus potassium iodide. That's going to make lead 2 iodide plus potassium nitrate. Balance this up real quick. So lead 2 iodide. This says all chlorides, bromides, and iodides are soluble except silver, lead, and mercury. So this is a precipitate. So we do have a reaction. In this next reaction, this reaction doesn't actually happen because copper 2 sulfate is soluble, hydrogen chloride is soluble. When the coppers come in contact with the chlorides, copper 2 chloride is still soluble. And when the hydrogens come in contact with the sulfates, hydrogen sulfate is still soluble. So you started with everything dissolved in water. Everything stays dissolved in water. Nothing actually combines to be removed from solution. So that's not actually a reaction. So that's why you don't form a precipitate or release a gas from solution or form water, you don't get a reaction. So in this case, once again, no reaction. For this last reaction, you have lead nitrate and potassium iodide, making potassium iodide and potassium nitrate, and lead 2 iodide is our precipitate. Because when you dissolve this into water, you get leads and nitrates and potassiums and iodides all moving around. The potassiums and nitrates form something that's always soluble, but when the lead and the iodides combine, they precipitate out. So our net ionic equation says that lead with a +2 charge reacts with 2 iodides with a -1 charge to form solid lead 2 iodide. So just keep in mind, in a net ionic equation, the precipitate is always your product, and over on the reactant side, it's broken apart into its constituent ions. And we have to have the two there to balance it for charge. Because it takes two iodines to go with our lead. So, hope this has been a helpful experience for you.